This is section 612. We're going to take a look at arithmetic and geometric sequences. We're going to determine if the sequence is geometric or if it's arithmetic. Now, I know I just highlighted the top in gold, but this is all a definition that we need to get down. So let's say we have a sequence. If there is a number d, so that my sequence starts with a value and then adds some sort of number d, like plus 2, plus 2, plus 2, plus 2, or minus 2, minus 2, minus 2. We call that an arithmetic sequence. We call that number d the common difference. So basically, if I'm adding or subtracting a number to every single value or every single term of my sequence, I know it's going to be arithmetic. If we look at this next sequence, if there is a number r, so that my sequence, this r is being multiplied by that initial value every time, we call that the geometric sequence, and that number r is called the common ratio. So we are multiplying. Now, I mean, you could think of it as dividing 2, but the idea would be that you're multiplying by a fraction, right? So multiplying 1/2 is the same as dividing by 2, right? So determine if the following sequence is arithmetic, geometric, or neither. Okay, so I need to plug in some values and see what's going on with this sequence. So if I plug in 1, I get 5 to the 0 over 3 to the 1. So that's going to give me 1/3. If I plug in 2, 5 to the 2 minus 1 over 3 to the second power. So that's going to give me 5 over 9. If I plug in 3, I get 5 to the 3 minus 1 over 3 to the third. That's going to give me 5 squared over 27. And so that's going to be 25 over 27. And I'll just do one more. If I plug in 4, 5 to the 4 minus 1 over 3 to the 4. That's going to give me 125 over, what is that, 81. And so usually by looking at about 4 of these sequences, you're going to be able to see the pattern. And if we look at this, each time I'm multiplying by 5/3. Multiply by 5/3. Multiply by 5/3. So because I'm multiplying by 5/3 every single time, it's going to be geometric. Let's look at this next one. Let's plug in some values. If I plug in 0, negative 1 to the 0 power over 2 times 0 plus 1. So that's going to give me 1 over 1. So that's 1. If I plug in 1, negative 1 to the first power over 2 times 1 plus 1. So that's going to give me negative 1 over 2, so 3. If I plug in 2, negative 1 squared over 2 times 2 plus 1. So that's going to give me 1 over 5. And if I plug in 3, let's look at one more. So negative 1 to the third. So that's negative 1 over 2 times 3 plus 1. That's going to give me 7. So I get negative 1 over 7. Okay, I'm not adding a number every single time, right? It's not plus 1 or plus 2 or minus 2. I mean, to get from here to here, it looks like I'm dividing, so I'm multiplying by negative 1/3. But to get to here, I don't know what I'm multiplying. It's not obvious. It's not the same as negative 1/3. So I'm not adding a number every single time. I'm not multiplying by a number every single time, so it's neither. So this last one, let's take a look at this. Go ahead and practice it, and then we'll show you the solution. All right, so let's go over it. If I plug in the values, if I plug in 1, you're going to get 1. If I plug in 2, you're going to get 3. If I plug in 3, you're going to get 5. If I plug in 4, you're going to get 7. Well, I'm adding 2 every time. So since I'm adding the same number every single time, it's going to be arithmetic. So what did we learn today? We talked about identifying if it's an arithmetic or geometric sequence. So an arithmetic sequence is where you're adding or subtracting, right? You can add a negative number by the same value every single time. A geometric sequence is a sequence in which you're multiplying by the same number every single time. And the difference between the two is one's adding and one's multiplying. And that's the way we can identify it. This does conclude our lesson. If you have any other questions, please leave them in the comments.